I'm starting with section 2.3 of Osborne, which is a chapter of game theory. Before this, we've done Prisoner's Dilemma. So today we are starting with another kind of game, which is called Battle of Sexes. Prisoner's Dilemma was a game where it was better for both the players if they can somehow cooperate. But when we talk about Battle of Sexes, it's a game where the interests of the players are not coordinated. All right, so let's see the game. So there are two players, player 1, player 2. I think that's not visible. Player 1 and player 2. The idea of the game is that the two players, there are different kind of versions of the game. One version say that it's a couple where the girl and the guy want to spend an evening together. So their interests are different. So girl wants to go for, say, a music recital or a movie, and the boy wants to go for, say, a game of cricket or soccer. In the book that you'll see, there are two different kind of music concerts. So the basic idea is that their interests are different. They want to do different things in the evening, but along with the fact that they want to spend their evening together. So let's see. Player 1 and player 2. I'm using a more familiar version of the game. You can read the book. It's giving a little different version, but just that the names are different, nothing more. Say P1 is the girl, girlfriend, wife, whatever. Maybe she wants to go for a movie recital and the boy wants to go for a match. So M stands for movie and G stands for a game of cricket or sport, whatever. Likewise, M and G here also. So the two actions available to the two players are either they can choose to go for movie or they can choose to go for the game. Likewise for player 2 also, either the player 2 can choose to go for a movie or for the game. So we'll draw the payoff matrices right now. And remember, the idea is also to spend the evening together. So we can't really have that, okay, let the girl go to the music recital and the guy go to the game. If that being the case, then they are separated from each other and they are both miserable because the idea is to be together through the evening. So let's write the payoffs. Since the girl prefers movie more than she prefers the game of cricket or something, so the payoff if they both somehow go for movie or they both choose movie is 2 for the girl and 1 for the guy. If they choose to, both of them choose to go for the game, then the payoff for the girl is 1 and for the guy is 2. Remember, payoff for player 1 is written first and then that of the player 2. Alright, and if the girl goes to the game and the guy goes to the music recital, the payoffs are 0-0. Some books will have negative payoffs also to show that they are really miserable without each other. And likewise here also, if the girl goes for the movie and the guy goes for the game, they are again separate or they are not together through the evening. So their payoffs are 0-0. So as you can see, if they do not cooperate with each other and if they are in separate places, that is either movie or game. If the girl is in movie, the payoff, and the guy is in game, the payoffs are 0-0. On the other hand, if the girl is in the game and the guy is at the movie, the payoffs are 0-0. So if they are away from each other, their payoffs are 0. If they are together, that's how the payoffs are. Now we look at the second kind of a game, which is called matching pennies. It's a simple game, a very simple game rather. Matching pennies is a game where two players are tossing coins and player 1 has a coin which he or she is tossing. Player 2 also has a coin which he or she is tossing. So let's see how things work out. If, say, the payoffs are like that, if, say, player 1 will win if both the coins show the same face. That means if suppose both the coins show heads, then player 1 wins. If both the coins show tail, then also player 1 wins. And the payoffs are like that. The person who is winning will be getting, say, 1 rupee or $1 from the player who has lost. So if player 1 has won, player 1 will be getting 1 rupee from player 2, and the other way also. and which will be if suppose the two coins show opposite sides. That means say one of the coin is showing heads and the other is showing tail. Then player 2 is going to win. And if player 2 is winning, then player 1 will pay 1 rupee to player 2 or $1 to player 2. So the payoffs would be something like this. So obviously the two actions are head and tails. Likewise for player 2, head and tails. And the matrix will look something like this. So if you are here, it's a head for player 1 and a head for player 2 also. So that means player 1 has won. So in that case, player 1 will receive say 1 rupee from player 2. So player 1's payoff will be 1, and since player 2 has paid 1 rupee to player 1, his payoff would be -1. Likewise, if you are in this block, that is tail for player 1 and tail for player 2, that means both of their coins have shown tail face up, then player 1 will receive again 1 rupee from player 2, and if since player 2 is paying 1 rupee to player 1, their payoff would be -1. And now look at this and this block. In this particular block, it's a tail for player 1 and head for player 2. So that means the coins are showing opposite faces. In that scenario, player 2 is going to win. And if player 2 is winning, player 2 would be receiving 1 rupee or $1 from player 1. That means player 1's payoff would be -1 and that of player 2 would be +1. In this case, player 1 has got head, player 2 has got tails. Again, opposite sides. Player 2 will win. That means player 2 will receive 1 rupee from player 1. So player 1's payoff is -1. And since player 2 has received 1 rupee, his or her payoff is 1. Okay. So this is a particular game where we see that it's no way that both of them will settle for one particular outcome. That means their interest or their preferences or their interests are totally conflicting each other. Player 1 will prefer same sides to show and player 2 will always prefer opposite sides to show. So it's a case where their interests are diametrically opposite to each other, or they are conflicting or strictly competitive as we say them. Okay, so that's another kind of game which is totally different from what we've seen in Prisoner's Dilemma, where there was a scope of cooperation, and what we've seen in Battle of Sexes again, where both the players would, as we will see later on when we do Nash Equilibrium, will ultimately end up spending the evening together. But here, it's not that any of the two players will settle down for one particular outcome. Now, there are many real life applications of this particular game, which is matching pen. It sounds very trivial what kind of silly game this is, but it has a lot of real life applications. For example, if suppose there is a new firm which is entering a market, and I don't know, you must have often seen that a new, younger, inexperienced firm tries to copy what already established firm is doing. And if you read the book through I'm reading that line from the book, that if suppose a firm has to choose how a product is to appear or look, the new product or the entrant would want that its product should look same as to the existing products in the market. Whereas the existing firm would always want its product to stand out, or the new entrant should not copy his or her product. Okay. So that's one application of this kind of a game. Another thing or another kind of game which is there in section 2.5. It's again a solved example in section 2.5. So that example is written in two different formats. One format is for n number of players. If there are say n number of players in the game. Another format for which we will be writing a payoff matrix is when there are 2 players only in the game. So the game is something like this, that it's a group of hunters which is going to hunt for a stag. So if they stay together collectively and they're attentive enough and they go for the pursuit of a stag, all of them do end up catching the stag. So each player has an option whether to be attentive in the hunt or to deflect. And if the person deflects, if a particular hunter deflects, then that person may catch a hare, a rabbit. But everyone would prefer a share in the stag than to have a rabbit. So the game is like that. Suppose there are 5 hunters. If they go together for hunt and they are attentive enough and they're all paying their attention towards the catch, they do end up catching a stag, and they will distribute the stag amongst themselves. So if there are 5 players, 1/5 of the stag. If there are 100 players, 1/100 of the stag. That's how it goes. Okay. Suppose one of the hunter is not being attentive enough and rather it goes to catch a hare for herself. So in that case, the hunter will end up catching the hare all by herself, and that hare would be not shared between amongst anyone. But any hunter would prefer a share in the stag over keeping a hare for themselves. So that means if suppose I have 1/5 of a stag, given that there are 5 players, and I have 1 hare all by myself, I will prefer 1/5 of the stag over a single hare for myself. Okay, but then there's a catch here, literally there's a catch which says that if players are not attentive, if few players decide to go and pursue a hare catch, in that case stag will not be caught. Okay, so it's like that. If all the 5 players pursue for a stag, they'll end up catching a stag and their share will be this in the stag. But say 3 of them are pursuing the stag, but 2 of them deflect and go to catch their own individual hare. In that case, the 3 who are still pursuing the stag, neither they'll be able to catch the stag nor they are able to catch the hare because they didn't go for it. So it's a tricky situation where if all of them decide to cooperate, then they get 1/5 of the stag. But if one of them deflects, that person catches his hare, but those who are still continuing to cooperate end up with nothing at all. Okay, so each player's set of action is simple, either to go for the stag or hare. So action would be something like this: stag or hare. Okay, so obviously you can't write the payoff matrix for that many number of players. So if we restrict ourselves to 2 players, in that case the game becomes a little more simple. If there are 2 players, if both of them pursue stag, they'll get a stag. If one of them deflects and goes for a hare, then that person will catch his hare, and the person who's still pursuing the stag will not end up with anything. He'll neither catch a stag, and since he didn't go for the hare, he'll not get the hare also. So the payoff looks something like this. Okay, so it happens. So if both of them go for stag, the payoffs are like this. They're sharing the stag. So you can have any number here. Okay, and if say player 1 deflects and goes for the hare and player 2 continues to go for the stag, then what happens? Player 1 catches the stag, but player 2, he's unable to catch the stag on his own, and he has not got the hare also. So the payoff is that person 1 will end up with payoff of 1, and since player 2 didn't catch anything, his payoff would be 0. Now if you look carefully here, for person 1, stag gives a payoff of 2, whereas pursuing the hare gives a payoff of 1. So as I was saying earlier, the game says that every player will prefer a share in the stag than having the hare all by herself or himself. Likewise, in this case, if person 1 goes for stag and person 2 deflects and goes for hare, then person 1 will not get anything and person 2 will get a hare. So payoff would be that. And if they both decide to go for hare and leave the hunt for the stag, then their payoffs would be 1-1. That means each of them will get their own individual hare, and this would be the payoff. So you can see that if they can somehow agree to cooperate here, they both end up with a much higher payoff. But if they both end up being hare, which is lower than that. Okay. Now this, example is used many times to explain arms race. Arms means race for ammunition, nuclear weapons amongst nations. Any nation, we assume, will prefer that both the nations, suppose we're talking about two nations and they're trying to have a treaty where nobody gets further nuclear weapons. So both the nations would want that they should not spend more on nuclear weapons. So that means if both the nations can somehow agree upon refraining from spending more or getting more nuclear weapons, then they both will be in a better off position. So the action profile for the nations would be something like this. And let me just erase this one. So action profile for both the nations would be something like this. Both the nations can have two options. Either they can refrain from spending more or getting more nuclear weapons, or they can get more arms. Okay. Likewise, the same action profile is for second nation also. And the situation is like that. If both the nations refrain, then both the nations prefer that outcome to any other outcome. So if both the nations decide to refrain, then the payoffs look like this. And that's the first best situation, the best situation in which both the nations can be. The second best situation in which a nation can be when that particular nation has got the nuclear weapon, but the rival nation is refraining. That means you get nuclear weapon yourself and your rival doesn't have it. So in that case, the payoff would be 2-0. Now someone might say that this payoff should be greater, but let's say we are assuming that getting nuclear weapons has a cost also, a big cost which nation has to spend. So maybe that cost pulls down this particular payoff. Likewise, if say nation 1 is refraining and nation 2 has got the arms, then the nation which has refrained gets a payoff of 0 and that which has got arms gets a payoff of 2. And the last situation is when both the nations have the arms. So if I talk in terms of preferences, say for nation 1 would prefer this outcome. First of all, I'm writing the numbering here in terms of preferences. That's the most preferred outcome. And this is purely on the basis of payoffs that we've written here. Second preferred outcome for nation 2 would be this, where nation 1 has got the arm and nation 2 doesn't have it. The third preferred would be this, where both the nations have got the arms. And the least preferred of all the four alternatives would be where nation 1 doesn't have the arms and the other rival nation has it. So here again, it will be better for both the nations if they can somehow cooperate and refrain from getting into an arm race. So this is another version where nations can benefit or players can benefit from cooperating.